Example 5. Solve the inequality x squared minus x plus 1 is less than or equal to 0. All right, so this is a quadratic inequality. The highest power of x in the whole thing is the second power, and we see the inequality symbol less than or equal to. Okay, so basically we are trying to figure out every single value of x that you can plug into this statement and get a true statement. Okay, so we are going to again do this by graphing and looking at the corresponding parabola. We need to make sure our inequality is in the correct format, and it actually is. We don't have to do anything to this one. One side is already 0, and there's nothing to multiply out, so we don't actually need to rewrite the inequality, but I'm just going to take the original inequality here and put it in this box. Okay, there's nothing we have to do here. Okay, so again, we're working with this inequality going forward. In this case, it just happens to be the same thing as the original. Okay, the non-zero side is going to be our f of x. Okay, so the f of x is going to be x squared minus x plus 1. Okay, we are going to graph this. It's going to be a parabola. Okay, we can go ahead and identify our a, b, and c. A is the number in front of x squared, that's 1. B is the number in front of x, which is -1. C is the constant, +1. And since the a value is 1, it's bigger than 0. That means this parabola opens up. All right, so in order to do a rough sketch of this parabola, we know it opens up, so the other piece of information we need are the x-intercepts. Okay, so let's go ahead, I'll go over here. To find the x-intercepts, we need to set the y value equal to 0 and solve for x. Okay, so remember, we're looking at the function f of x is equal to x squared minus x plus 1. So if we set the f of x equal to 0, that's how you set y equal to 0. So we're going to get 0 is equal to x squared minus x plus 1. This is what we need to solve in order to get our x-intercepts. Okay, it's up to you. You can either factor or you can use the quadratic formula. Regardless of which method you use, you need to make sure one side is 0 before you even start. Okay. All right, I factored in example 4, so I'll go ahead and do the quadratic formula in example 5 just to change it up. Okay, we've already identified the a, b, and the c. Okay, so we just need to go ahead and plug it in. We know the quadratic formula tells us that the solutions to the statement are going to be -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we just need to plug in our a, b, and c. All right, so here we go. So we have -b. Okay, this negative sign is part of the formula. So I'm highlighting it in yellow. So we have the negative sign, and then we need to write down b. B is -1. So be careful there. This is going to be the negative of -1. Plus or minus the square root of b squared. So I'm going to multiply b by itself, minus 4 times a times c all over 2a. Okay, so 2 times a. Okay, so this is what it looks like if you plug in. Let's go ahead and simplify to get our x-intercepts. So negative times negative will turn this top into +1, plus or minus the square root of, underneath the square root, we have -1 times -1 is +1, minus 4 times 1 times 1, that's 4. The bottom is 2. So if we keep going here, we're going to have 1 plus or minus the square root of -3 all over 2. Okay, now at this point, okay, you're like, uh-oh, because I see a negative under the square root. Okay, this is bad. Okay, we cannot have a negative under the square root. Okay, so cannot take the square root of a negative number. Okay, So we saw something like this when we were working in section 4.3 and we were learning how to graph a parabola by hand. If you encounter a situation like this, remember, we were trying to solve for the x-intercepts, and in doing so, we encountered a problem. So what we concluded in section 4.3 is the same thing we'll conclude here. There aren't any x-intercepts. Okay, so there are no x-intercepts. Okay, so what does this mean? Can we even graph our parabola? It doesn't have any x-intercepts. Okay, well, you still have to have a parabola. Okay, the graph still exists. Okay, it's just going to be a parabola that opens upward that doesn't have any x-intercepts. Okay, so let's try to figure out what this thing is going to look like. Okay, again, we don't have to go and spend time finding the vertex or calculating specific points on it. Okay, we just need a rough sketch of what it looks like. Okay, so here's the x-axis. Your parabola can never ever touch or cross it. There aren't any x-intercepts. Okay, we know it opens upward. Okay, it opens upward. So if you draw it like this, you're going to have x-intercepts. Okay, so that's not right. Okay, so you might think, okay, well, let me draw it down here. Okay, good, I don't have any x-intercepts. Okay, well, remember, the parabola is going to keep going up forever. Okay, so yes, you do. Okay, the only way to draw this parabola so that it opens upward and it has 0 x-intercepts is like this. It is totally above the x-axis. Okay, the vertex is above the x-axis, wherever that vertex is. Okay, so this is how you draw it. Okay, so if it makes you feel better, then go ahead and find specific points. But again, it is not necessary. All right, so this is the graph of our f of x. Okay, let's go back to the inequality because that's ultimately what we want to solve. Okay, so we know that the way we set this up, f of x is x squared minus x plus 1. That's the parabola. That's part of our inequality. What I just highlighted in blue is the f of x. So we are really trying to figure out when f of x is less than or equal to 0. Okay, f of x is the same thing as y. So basically, we're trying to write down the x values of the parabola where the y values are less than or equal to 0. Okay, so if we translate this, where does the parabola have negative or 0 y values? Okay, we know negative y values occur below the x-axis. And the thing is here, this parabola is never below the x-axis. Okay, so basically, I'll write this here, parabola is always above the x-axis. It's never below or on. Okay, so again, the solution to this inequality is going to be where we have negative y values on the parabola. Well, we don't have any negative y values on the parabola because the parabola is always above the x-axis. Okay, so as a result, this inequality has no solution. Okay, this means that if you pick any x value randomly, any x value that comes to mind, decimals, fractions included, if you plug it in to the original inequality, you're going to get a false statement always. Okay, we can just kind of eyeball it and check something here. Okay, if I checked x equals 0, okay, and I plug it into the original inequality. Okay, so x squared minus x plus 1 is less than or equal to 0. Okay, let's check it out. We should get a false statement because every x value we plug in should produce a false statement for this inequality. Okay, we'll get 0 squared minus 0 plus 1. Is that less than or equal to 0? If you simplify the left side, that's going to give you 1 is less than or equal to 0. We know that's false. Okay, so just kind of eyeballing a thing or two, it seems to agree with what we found, that there is no solution, no value of x that makes this inequality a true statement.